Good morning, chemistry students. We are going to start Chapter 8, Section 2, and we're going to focus today on classifying reactions and combination reactions. The goal at the end of Chapter 8, Section 2 is that you will be able to write and balance the 5 different types of chemical reactions. So, on our outline, we're starting with 8.2, types of chemical reactions, classifying reactions, the 5 general types of reactions. If you take a look at your outline, you should be able to see those 5 general types already listed on your outline. The first type is a combination. Or synthesis reaction. Again, the reason that I give you the other name is because depending upon the college professor that you have, you might hear this reaction called a combination, you might hear it called a synthesis, and I want you to know that they're the same thing. Another type of reaction is decomposition. So if you kind of start to think a little bit about the names here, you can start to predict a little bit what might happen in these reactions, right? In a combination or a synthesis reaction, right? If you are combining things or synthesizing things, you are making things, okay? For a decomposition reaction, again, when something decomposes, it breaks down. So in a decomposition reaction, you're going to see things break down. The third type that we'll talk about is a single replacement reaction. The fourth type is a double replacement reaction. And the final type is a combination reaction. Sorry, not a combination. Combustion reaction. One of the things to keep in mind is some reactions may be classified as more than one type. However, most of the reactions we do are going to be, and we talk about, will be pretty simple and fairly clearly fit into one of these 5 categories. So, the next couple days, we're going to cover one of these types of reactions daily. So today we're going to talk about combination and synthesis reactions. We're going to start with the definition of a combination or synthesis reaction. In a combination or synthesis reaction, 2 or more substances combine to form a single substance. Okay, and again, that's probably what you would expect based on the name of it, right? It's a combination or synthesis reaction. We're going to take several things and we're going to combine them into one. Each time we talk about one of these reactions, we're going to consistently talk about reactants and products. The first thing we want to talk about here with reactants is how many reactants are there going to have to be. Again, if you look at that definition, you should be able to answer that, right? Because our definition says 2 or more substances combine. So for our reactants, we're going to say that there's more than one. Okay. Now, what those more than one can be, there's quite a bit of variety here. It's usually 2 elements. However, it could be 1 element and 1 compound. Okay, it even could be 2 compounds. For the kinds of reactions you're going to be doing, they're typically going to be 2 elements. But do know that you could have these other ways to combine or do a combination reaction and produce a product. We're also every time going to talk about the products. And again, if we look back to that definition, it says 2 or more substances combine to form a single substance. So one of the characteristics of a combination reaction is the product is that there's usually only one. And again, for your purposes, there'll just be one. I say usually because occasionally something else happens and things break down. And if we're combining things, it's always going to be a compound. Okay, so for our purposes, part of what you're going to have to be able to do by the end of this section is given a big list of, let's say, 20 or 25 different chemical reactions to be able and go through and identify them as to which type they are. And so what are you going to look for to know that that reaction is a combination or synthesis reaction? You're going to look for the fact that you have 2 or more reactants and only 1 product. If you only have 1 product, then it has to be a combination or synthesis reaction. Now, for combination and synthesis reactions, it is hard to predict the products. So oftentimes you won't be asked to do that. And if you are asked to predict the products, it's going to be something like this example that we're going to do together right now. So this example, I've given you the sentence here. Our sentence for this example is the formation of aluminum chloride from its elements. So again, I'd really like you to have that sentence because remember, as we are starting to write and balance chemical equations, we want to remember to go through all of the steps necessary to correctly write and balance a chemical equation. Typically, you're going to be given a sentence like this example. The next thing you always want to do is do your word equation. After you do, and remember, only symbols in a word equation are plus signs and arrows, and the purpose of that word equation is get rid of extra information. After we have our word equation, the next thing we'll write is our skeleton equation. Remember, the difference between a word equation and a skeleton equation is, in a skeleton equation, everything becomes symbols. We're going to use our periodic table and our element symbols, and we're going to make everything symbols. So we'll write the symbols, okay, or the formulas for the elements, the molecular compounds and the ionic compounds. And then once we have our skeleton equation, we have to make sure our equation follows that law of conservation of mass. So we have to make sure that we have an equal number of all of the atoms on both the reactants and product side of the reaction. So again, we're going to work through that right now. So again, the first thing we want to do is do our word equation. Now, this talks about the formation of aluminum chloride. So what that means is actually aluminum chloride is our product. Our reactant is its elements. So what elements make up aluminum chloride? Aluminum plus chlorine. The formation, there's our arrow, okay, aluminum chloride. So there's our word equation. Now we want to write our skeleton equation. So again, I'm going to do that arrow. Reactants go on the left, products go on the right. Aluminum, our formula for aluminum, because it's just an element, is an Al. Remember, we want to leave space in front of our formula so that we have room to put a coefficient. Chlorine. Now, chlorine, remember, we have to be careful about, right? Because chlorine is part of Dr. Brinkelhoff. And here, chlorine is not in a compound. So when I write chlorine, I have to write it as Cl2 because it's diatomic. That brings us to this, aluminum chloride. Aluminum chloride is a compound. So remember, there are those questions we need to ask ourselves so that we correctly write the chemical formula for this. The first question is this compound ionic or molecular? It's ionic because aluminum is a metal. Remember to write the formula for an ionic compound. There's those 4 steps. You should be able to rattle those off right now. Symbols, charges, crisscross, lowest whole number ratio. So our symbol for aluminum is Al. Its charge is +3 because it's in group 3A. And again, it's easier to lose those 3 valence electrons than to gain 5. Our symbol for chloride is Cl, and its charge is -1 because it's in group 7A, and it's easier to gain 1 electron than lose 7. So we have our symbols, our charges, we're ready to crisscross. Remember, it's just the numbers and not the signs, and we don't have to write 1. So we're just going to write AlCl3. Now we have our skeleton equation. So this is our skeleton equation. Now it's time to balance it. So we have 1 aluminum on the reactant side and 1 aluminum on the product, so aluminum looks fine. For chlorine, we have 2 chlorines on the reactant side and 3 chlorines on the product side. That means that the lowest number, I can make them both as 6. So to get 6 chlorines on the reactant side, I'm going to use a coefficient of 3 in front of chlorine. And to get 6 chlorines on the product side, I'm going to use a coefficient of 2 in front of aluminum chloride. Remember, I have to put it in front of the whole chemical formula. So remember now what that means is now I have 2 aluminums here. And over here, I only have 1. So to get 2 aluminums, I have to add my coefficient of 2 in front of aluminum on my reactant side. I think it's balanced now. I want to check it. So checking it here, I have 2 aluminums on the reactants and 2 aluminums on the products. I have 2 times 3, so 6 chlorines on the reactant side, and I have 2 times 3, 6 chlorines on the product side, so my chemical equation is properly balanced. So in review, okay, part of what will be really important is that you're able to identify a reaction as a combination reaction. And again, what we're going to look for is we're going to look for more than 1 reactant and 1 product. Typically, it's going to be hard to predict the product of a combination reaction, so many times you will not be asked to do that. So that brings us to what your homework is for this evening. You have a balancing chemical equations worksheet that will be in Google Classroom that you will need to do. I will tell you on that worksheet the chemical equations are already written for you, so you don't need to rewrite them. You may just write the coefficients in. So just add the coefficients necessary to balance the equations. Okay, it's not necessary to rewrite everything. So thank you, and I will talk with you tomorrow.